volumetric video. And sometimes I just simply call it Skype on steroids, right? So instead of seeing a 2D video or a Zoom 2D video, we can see a 3D video. And wearing a device like the HoloLens, you can see the other person as a 3D hologram, right?
Now,
and in this video here, you can actually see a keynote from Microsoft's Ignite, where they presented our solution, our HoloBeam solution. And you can see the setting, right? It's a typical conference room setting, a lady wearing a HoloLens, the other two people, probably not, and they can see the scene on the screen, right? And so we have a remote expert that is in a whole different location, right? He's not physically present in the same location. This is the guy, right? And so he's sitting in front of a 3D camera. And what we're using here is a depth sensing camera, a Kinect, an Azure Kinect, which provides us not just the color data from the camera, but also the depth data, the distance. And so what we developed with HoloBeam is a solution where we can package it up and stream that real time, depth plus color, and then reconstruct it in real time on a device like a HoloLens as a point cloud. And so you can see the other person as a 3D hologram, right? So that's nice. Plus, we're talking about collaboration today, right? We also have collaboration built in. So what you can see here in the video is a 3D model. And again, it's actually a digital twin again, because these green lines you can see there, these are temperature sensors in this building, right? And so this could be a gentleman that is a remote expert for, solving these temperature issues they might have. And so instead of traveling there, he can be remotely present and they can collaborate with each other. And since we synchronize the coordinate spaces, they can actually point at things on the 3D model, on the digital twins, and figure out certain issues without having to be physically present there, right? And that saves a lot of time and a lot of money, of course. And in general, these days, we cannot travel that much anyway. So this is where we're going, and we just need 5 to 10 Mbit connectivity bandwidth, right? So typically, internet connection works fine. I've used it with mobile hotspots at conferences and so on. So it works just fine, right? Alrighty, so let me show you a demo. And for that, I will move is over here. All right, so you should now be able to see actually the Zoom screen sharing thingy here, right? And so what I'm going to show you is I have HoloBeam running right here at my desktop. And so what we developed is a thing called HoloBeam Bridge, which allows us to bring HoloBeam content into any conferencing solution, right? And so what I'm going to do here is I will change my camera. You can see this is all the cameras on my computer. And here you can see a HoloBeam Bridge. So this is like a virtual camera driver, if you will. And so you can use in any kind of setting. And so now you should be able actually to see me in this. Let me actually stop sharing real quick. Wait for that. So yeah, there you can see me in HoloBeam, right? In full glory here as it's running on my PC. And so again, what I mentioned is with HoloBeam, we're supporting like a HoloLens. And if you have a HoloLens or a virtual reality head-mounted device where you can see stereo 3D, that's of course much better, right? But with this HoloBeam Bridge, we can integrate it basically into any meeting solution that you might have, Teams, Zoom, Skype, whatever. And you can still be, kind of present with HoloBeam and do things like this, right? I mean, look at this. This is really 3D. This is no fake. Again, live right here for you. And what we can also see is I have a bunch of 3D models here, company logo. Here we have a snippet of a human DNA, and we have our model viewer, so I could load many more models. And, of course, I can also select them here. I can move them around, do crazy stuff with it. And all of that fully integrated into a Zoom meeting, right? Or any other meeting solution without having to install any other client stuff, right? Of course, you would need the Kinect or something like that, a 3D camera. But again, yeah, very simple, very easy to integrate. And so that's going to help quite a bit. Alrighty, so glad the demo worked. You never know, right? Actually, yesterday I got a Windows update and that messes up all of the stuff. The Kinect couldn't be accessed. And so I'm glad I was able to fix that somehow today. All right, let me switch to the other camera and start screen sharing again. All right. Okay, good. Can you see my slide deck again?
Yeah.
Yeah, okay, great. All right, so let's move on forward. Here's another demo with HoloBeam where we are having it running on a looking glass. And a looking glass is a volumetric video display. And basically that allows you to see 3D content without having to wear any glasses on a normal display, right? I mean, I'm really, when I rotate my phone camera around it, you can see that it's really showing you 3D data. Of course, limited resolution, limited viewing angle, and small device, 9-inch. But you know, this stuff is growing rather quickly, and the Looking Glass folks are doing an amazing job, like increasing the size. This is the Azure Kinect, by the way. Like that's the camera that is standing here on my desk, where you could see it before. But so, like I mentioned, you know, supporting different devices for actually viewing HoloBeam content. Could be HoloLens, VR HMDs, or things like that, like a Looking Glass, right? We're also experimenting with AI, deep learning networks for depth estimation. So what you can see here is actually a deep learning model that learned how to estimate depth just from color information. So in the end, what we can do is we can input just a normal YouTube video, like you can see here with Satya Nadella. It will output the depth estimation, and then we can basically use that to actually 3D transform the 2D video, right? Still quite resource intensive, early research there. You see some artifacts. But it's promising and might be useful for scenarios where you don't have access to a 3D camera like a Kinect, right? But you still can participate in these scenarios. All right, let's talk a little bit more about AI and combining it with mixed reality and the HoloLens. So what I'm about to show you is a video that was recorded straight on the HoloLens. This video on the HoloLens 1. But I also have it running on the HoloLens 2. So what I did here is I trained a neural network, a deep learning AI model. And I did that with customvision.ai. That's a cloud service from Microsoft where you can upload a photo. Like, think about it. You have a bunch of photos, a set of photos, upload them, give them a label, take another set of photos from a different object, give them a label. And then you can easily train it with a web interface. And at the end, you get a REST API, which you can use, right? If you can send images there and it will recognize and tell you what it is. But what I did here is actually something else. I exported that pre-trained neural network as an ONNX model, ONNX. And that allows me to run it locally without having to send the data to the cloud, right? It all runs on the device itself, on the intelligent edge, if you will. And yeah, so I had my custom trained model here. And you can see it here in a moment in the video.
This might be a car wheel 3.5 meter in front of you.
So on the HoloLens, recognizes what it is, tells you what it is with text-to-speech, right?
This might be a matchstick 1.1 meter in front of you.
And I also use the spatial mapping for measuring the distance, right? Which is built into the HoloLens.
This is likely a minibus 3.1 meter in front of you.
And the nice thing, again, is all running locally, right? Low latency, basically, right? We don't need to send any data to the cloud, which is pretty awesome. But you might wonder, well, I know what a car mirror is, I know what a hammer is, and so on, right? Why would you use that? But think about scenarios where you have low vision or blind people, right? You can help them and enable these kind of scenarios where you basically tell what's in front. Or think about, for everyone, training instructions. Or think about going to IKEA, right? And you buy a package and you don't know what it is. You just look at it with your HoloLens. It will recognize it and will tell you what that object actually is, and then show you on top of it holographic instructions how to assemble it, right? Here, real quick, the nice thing is if you're using a HoloLens or Windows in general, they support an API, a part of Windows AI API set called WinML, Windows Machine Learning, which allows me to take these ONNX models and run them either on the CPU or GPU, hardware accelerated. And here in the screenshot, you can see that when I run it on the HoloLens on the GPU, and that is the HoloLens 1, what you can see here, it's 4 times faster than running it on a CPU, right? And if you have like an AI accelerator chip, like whatever, right? Like some mobile phones have these days, of course, it's even faster on that. And that's really nice because like low latency, I can combine best of both worlds, right? Train it in the cloud, resource intensive, scalability there, and then download it to the device and run it there with low latency and fast results. All right, let's talk a little bit more about these large-scale digital twins and basically Azure remote rendering. And so what you can see here in the video is a 3D model that has 18.7 million polygons, like not 1800, but 18 million polygons or 19 million polygons. And you would never be able to render that on the HoloLens, right? So this video was recorded on the HoloLens while wearing the HoloLens, right? Which also means we see some issues when it's sometimes a little bit lagging or jittering, but that's not what you see when you wear the device yourself. That's really just because we're recording a video at the same time, which is a little bit resource intensive, right? This mixed reality capture. It also throttles the frame rate to 30 frames per second. When you don't record the video and experience it yourself with your own eyes, you get 60 frames per second. Anyway, super large model. You would never be able to render it locally on the HoloLens, right? HoloLens can render up to 100, 200,000 polygons. And so that's a whole different magnitude here, right? And so Azure Remote Rendering, what it's doing, it's basically taking the input data from the HoloLens, like the 6 DOF tracking, the head rotation and the movement, and the hand input, streams that to one of these powerful Azure GPU machines where it's being rendered remotely, then streams back the result as a video frame for the left and the right eye and the correct depth, and then blends that into your locally rendered content at the correct position, right? And that's pretty amazing because there's almost no latency. And I was very skeptical initially if it would work that well, and I was highly surprised that it works really well, and you almost have no latency. Really works really well. And you can see here on my phone, it's 16 Mbit using in this scenario, like let's say 20 Mbit is a good. Microsoft recommends a download bandwidth of 50 to 100 Mbit, but I also already used it with LTE 4G mobile phone hotspot. But of course, 5G will even accelerate these kind of scenarios, right? And that's great because we can take, you know, CAD models, computer-aided design models that every engineering department in the world creates and take them as they are. Because what we had to do before is we had to take these super huge models we got from our clients and reduce them, you know, simplify and reduce the mesh and you know, remove stuff basically to be able to render it on a device. But with remote rendering, we can take these full models and create our digital twin rather easily by taking the model directly, right? And so that's a great benefit. And of course, a little bit future vision, right? Think about smaller form factors, right? We can basically in the future reduce the form factor and the size of these devices to something like this maybe in the end, right? Because we can offload the heavy lifting on some cloud computing. You can also, if you don't have a CAD model, you can also generate digital twins differently. Like here, I have a photogrammetry model, which is done by taking lots of photos of an object. Here, the Pinchot sculptures in Rome, and then you have a 3D model. So if you don't have a digital twin as a CAD model available, you can create it with photogrammetry, and again, render it with Azure Remote Rendering. And we can even render the predator of all times in the HoloLens to quite some detail. So this is the SARS-CoV-2 coronavirus. From University of Glasgow. It's a 2 or 3 million polygon model, which I rendered with Azure Moon Rendering pretty nicely. And so we can go down quite some detail and check out the proteins and stuff. Not to the atomic level, but pretty near to that, right? All right, so a little break here. Let's talk about the AR cloud. And sorry, I'm going really fast because I have so much good stuff I still want to show you. The AR cloud, what is that? The AR cloud, the augmented reality cloud, is basically a digital copy, a digital content layer on top of our physical world, which means we can have an understanding with all of our devices of the real world, and then we have a digital copy of our whole physical world, not just an object, but the whole stuff, right? Gardner also says it's transformational, super highly relevant in the next decade, or now the current decade. And yeah, will change a lot, right? A lot of companies working on it. Google Cloud Anchors, unfortunately, no persistence. So these anchors, like these reference points in the real world, will be deleted after 24 hours. Microsoft with Azure Spatial Anchors is the only one that has true persistence. They are persisted as long as you want. And by the way, most of the research there is actually done in Zurich by the HoloLens Mixed Reality team in Zurich, in Switzerland. Mark Polyface Group is actually running a lot of the core research here for the computer vision under the hood. But that just aside. And here's a little video that shows you actually how it really works. So you have all these people running around with their spatial computing mobile devices, right? And each of them is generating a little 3D scan of the environment. It's generating a little like you know, digital replica, but just a small puzzle piece, right? And the power of the AR cloud is bringing all of this together and have this, right? Each of them generate just a little snippet in their own device, but uploading all of that to the AR cloud and merging it together, we get a whole digital replica here of this office. And so what this allows us is, of course, we have a digital 3D scan, but even more important, we have the reference locations, right? Okay, can you still hear me? I was a little cracking or something.
Yeah.
Okay, good. So here's an example where I'm using Azure Spatial Anchors on my Android and my HoloLens, because we can enable cross-platform and shared scenarios, right? So I created such an anchor on my Android device. What you can see now, here's the Android device, and I'm recording this now with the HoloLens, right? So first-person view of the HoloLens. Again, this anchor, this reference location in our AR cloud, in our digital copy of the real world, was generated on the Android device, uploaded to Azure Spatial Anchors, ASA, then downloaded from ASA on the HoloLens, and then the HoloLens mapped it into its own tracking, its own understanding of the real world. And you can see it's really precise, right? We're talking about centimeter range precision here, and that's thanks to advanced computer vision algorithms. Of course, it's not using GPS or anything of that, because we would get like meter range precision. But with this technology using computer vision, we get centimeter range precision, which is pretty fantastic. And cross-platform, right? Android, iOS, HoloLens 1 and 2 can be shared across platform. And persistence, right? So here's an example. When I was in Seattle last year at the Pike Place Market, I created one of these anchors there with our company logo again, then came back a few days later and relocalized it. So it refound that anchor, right? What I did is I used my phone, scanning a little bit around. You will see that in the next video. And basically, then it relocalized. It figured out, okay, I have the digital copy of my real world. I think the reference is here. And then it figured out, okay, I have my anchor here set, and then reloaded that, right? And you see it's different days, right? It was raining when I created the anchor, and then it dried up when when I basically relocalized it. And it's still able, even though it's using computer vision, like analyzing camera frames, still able to relocalize. And that's quite a milestone, actually, because that's a high challenge, of course. Let's talk about some use cases. And one of them is, of course, think about collaborative design reviews, right? Where you can take these kind of cross-functional teams that all have their own devices, but they can share the same content. And here's an app we built for Microsoft for Azure Spatial Anchors as a demo. And you can see that recording on an Android phone. So what a gentleman is doing, he's scanning around, like I mentioned, gathering enough computer vision information, so-called feature descriptors, so that the anchor has enough information to later on relocalize, right? Then he creates the anchor. Now take a look at the lady. She's using an iPhone, and she's scanning the same space for relocalizing the anchor the gentleman on the Android created, right? And so they can have the same reference location, basically, between the Android and the iOS device. And what we also integrate is OneDrive. So you can load a 3D model from OneDrive, whatever that is, right? And so we can enable these cross-platform shared scenarios, like I mentioned. And we also have real-time interactions. For this one, we're using a Signal on Azure. You can see actually the lady moving around the 3D model now, which is represented on the Android phone. We got the recording here. And so you can enable these consumer scenarios, right, where you can move it into a certain space and figure out, hey, would that new kitchen sink fit into my kitchen, right? But think also about other scenarios. I was at a lot of chemical companies, and they always have to challenge super highly dense facilities, right? Lots of machines, lots of piping, all of that stuff. And it's a challenge for them to actually place new objects. But using AR, they can figure it out in a one-to-one scale if it would fit. And with this technology, they can even persist it, which means they can have a small meeting, leave the anchor there, tell the other group, hey, we left something there, please check it out, right? All right, let's talk about another one, free capture visualization. So like I mentioned, we can persist these kind of sessions. We can persist these anchors and reload them. So what you see in this video is I reload an anchor that I persisted in front of my house. So I do a little bit of scanning here, right? Scanning a little bit, and then relocalize the position where I was before, the environment. And then it found it and shows me this 3D model I attached to the anchor. And that's a wooden Easter bunny. On the left side is the 3D digital twin. On the right side is the original one, right? And that's pretty cool. Like, look at the 3D scan, how good it is. And you guess what? I did that with this phone. Like, isn't that crazy? I mean, that's a Samsung S20 Plus. It has a depth camera. It has a time of flight camera, similar like the Kinect. Not the quality like a Kinect has, but still very good, as you can see here. And to create this 3D scan, I just walked around it like half a minute or so, and then I got a 3D model out of that. And so I can easily create these kind of digital twins these days with mobile 3D scanning even. And then I can position them in augmented reality, and I can share these kind of things with other devices cross-platform. Plus, I can persist it, right? I can load it to a later point. And of course, we can rescale and all of that with our app. And so basically, I could tell my uncle makes these kind of Easter bunnies. And so I could tell him, hey, can you make me a new one that is a little bit larger or something like that? And give him the right size, because I can measure it in relation to the real world. All right, last block here before I'm finished, wayfinding. Wayfinding is also possible because if we create one anchor, we can actually not just create one, we can create multiple. So they get connected with each other. Think about a graph, like a linked list almost, right? But it's rather a graph. And so here's one scenario. Think about there's a machine in a certain facility that breaks down, has some issues. And there's one engineer in the control room that sees like a blinking LED or something. What they need to do now is they need to use a lot of paper, find out where's the machine, how can I repair it? Now figure out if we would use modern technology, right? We would use AI that just hold up the phone or take a HoloLens. It will recognize with object recognition what machine is failing, then loading the dynamic wayfinding information and showing them AR overlays like green arrows on the floor that guides the user where they need to go. And on the machine, we can show repair instructions real time. how to repair the machine. And that could save minutes. And even if it's just seconds, that can save 100,000 of Swiss franc, euro, dollar, whatever your currency is. But that can save a lot of money in the end, right? So huge business value of these kind of scenarios. All right, we just talked about visual content on top of these anchors, right? But of course, it can be actually not just visual, it can also be spatial sound. And this is what's being used in this application here called Seeing AI by Microsoft's AI for Good initiative. So this blind lady is using this application to basically navigate through the scene by using audio, right? So let me tone it up here.
Starting from the lobby of Studio C.
Yes.
Pan your phone to map the room. Follow the audio breadcrumbs to conference room 1200.
Where can I sit?
Pan your phone to map the room. Table at 12 o'clock, empty.